Hello everyone, welcome back to my channel, the Python Gurukul. Today we'll be talking about calculate runtime in Python. We'll be also exploring run or elapsed time, then what are the different options available in Python to calculate the time, and then we'll be taking a look at one of the sample program. Let's start with the talking more around the runtime, why we need it. So many times we want to calculate that the program we have written, how much time it is going to take. Or let's say we have two programs. We want to compare the two programs and find out which one is better with respect to the timing through the runtime. Then we need to have some tool which is going to help us to find the execution time or the same thing we call elapsed time. To do that, it's a very basic funda. The one we use in our real life, one is start the timer, do the job, and end the timer and find out the difference. Exactly the same thing we'll be doing, but here we'll be doing with the help of some modules. There are lots of modules, and as of today, I know about three modules which we can use for date and time calculation. One of them is time, and it comes with a standard Python installation. So we don't have to install any additional module here. Similarly, there are date time and time it. These all modules are very popular and available for all thing we possible thing we can think about the timing calculation. Let's simplify it. How we'll be doing in the Python. So as we said, we'll be using the time module. So we are just importing the time module. Start the timer. We are just saying that call the time function from the time, and it is just going to return the current time. Call the program body, call the Python program, whatever we want to execute after that, and then call the timer again. We are just saying the time dot time, and now we are calculating the current time. And once we are done with the calculation, we are just subtracting time from end to start, and this particular duration will be the time taken to run our program. Let's take a look at one of the sample program. Again, we are importing the time module. I have two different function for the purpose to showcase that how they doing the same thing but two different way can take different time. So in one function, overall we are creating some list array items. With the number which we are providing, we'll start with from 1 to the number and we'll square those and we'll create the list. In the first definition, in the first function, we are using the for loop and appending all the items to the list. To do the same thing in another function, we are using list comprehension. We have already talked about this one a little bit while learning the for loop. Again, we'll be talking in great detail about the list comprehension, but just for now, we have used the list comprehension to do the same thing. Create the list of squares. Now, this two line is very important and new for this particular program. One, we are starting the timer. Then we are calling our function. Line number 16 just say that whatever we wanted to do, wanted to calculate the time on, will go between these two times. So we have the begin time, we have the end time, and then we are just printing here. So at this point of time, we know that time taken for the for loop. Again, same approach, start the timer, call the program, end the timer, and calculate the difference. So I have given 1 power of 6. So let's see how it goes. And okay, the program was so fast that it took not even a 0 second. So let's increase little bit. How about calling the 10 instead of instead of 10. And same thing here. Save the program. Go to the command prompt. Maybe program was not saved. Let's do that once again. Okay. So, ah, somehow, let me do this. I want to do the power 6 and power 6. And now it should be interesting. So we just increase some numbers so that it will take some more time. So this time it took close to 1 second, but we can see that this one took zero point 0.9 and this one took 0.84 second. Let's run again. And this time it took this much, but it is not the next time it will take the same. It will be different because it is interacting with other processes as well. And this time it took 7667. So what we wanted to do, we wanted to compare these two functions, square list and square for loop. And clearly we see that with the for loop, it is taking more time in all situations. Here it took 98 with respect to 84, 76 with respect to 67. So we can showcase that for loop is not good solution for this scenario. This should be going for list comprehension. So why we are talking about the timing in so detail? Because as we are moving towards the advanced Python programming, we'll be talking the time complexity and the space complexity. That's where I wanted to give you heads up around the time. Hope you like my video. If you like, please share and subscribe. Thanks for watching.